Let's talk about that today. In this selection and application process of connectors, this ambient humidity, the impact of some characteristics of the connector. What about humidity? In fact, everyone in our daily lives is very common, especially in the South. This goes back to the water on the wall in Nanchen. Is this very serious? This humidity can everyone, you will get it. Of course, what about this plum rain season in many places? We all have that experience, more or less. The moisture content in the air will be very high. What about in our daily lives? That's a lot of furniture, including our daily necessities. You'll also find this strong sense of moisture, or even some are visible to the naked eye as water droplets. Phenomena like water droplets. What about the connector? It is electronic components that work with electricity. So this wet water, especially in this environment with high humidity. This pair of connectors. Yes, what about this kind of working environment with electric load? There will be a relatively large impact. We have a regular daily experience. Then this is directly this humidity. It will seriously affect some of our electricity, some insulating properties of this appliance under normal circumstances. For example, we use a dry one. Or is it, a dry item? Let's say it's a plastic part. Or what one looks like. When we normally power on, can't we feel this? It claims to have this kind of leakage phenomenon. But if this item, we soak it in water and pick it up, this is equivalent to, in some conditions with relatively high humidity, some extremes of condition. At this time, we will obviously feel, here it is. There is some slight leakage of this touch. That's one effect of humidity. This is the most obvious impact. It will directly reduce the insulation resistance of the object. What else? Because the humidity is relatively high. And what about our connector? It's a multi-component. This is a comprehensive complex one by one. What about when the humidity is relatively high? Connected conductors. Because it has some, like electroplating, for example, or surface treatment, such, chemical treatment processes. What about metal? Is it produced in high humidity? It's extremely easy to generate some. Chemically corrosive, a very slow process of chemical corrosion, because it's in the air, inside our air, except in the air, except for the oxygen we often talk about. Other than nitrogen, it has more, like carbon dioxide, sulfur dioxide. It's like sulfur dioxide. And what about gases like carbon dioxide? It's actually, we all know that when we study chemistry. As long as it comes into contact with water vapor, it can produce some weak acids. It's the same environment. For example, what is in our metal conductor? Some say it's like zinc, like aluminum ore. How about some materials like this? It is used in practical applications. Because of these weak acid environments, it produces some oxidative corrosion of this. What about the results of oxidative corrosion? Like some copper carbonate, copper sulfate, things like that? It will make contact with our surface. This is especially our copper parts. It is easy to produce this kind of copper sulfate on it. Patina, what about this thing? It's very easy to make this. The surface of this material? It's easy to make our material surface is to increase its contact resistance. What about once the contact resistance increases? For our entire connectivity application, if it is a high voltage and high current product, is the fever too high? If it is some of our communication products, if the contact resistance is too large, will it cause your signal to be distorted? Or is your loss too large? That was such a situation. At the same time, what about this high humidity? Because once the humidity and temperature get together, it will have some special phenomenon. Like in our north, especially at this high latitude, Harbin in China, further north or Russia, such a weather. We are friends in the north. There should be such an experience. What if we leave our cabbage outside, especially in winter? I woke up the next morning When we step on it, you will find that the cabbage is directly stepped into powder. Isn't it like we are in the South? We'll step out of the water. What about this phenomenon? It's actually, what is this called? A very, very obvious manifestation of low temperature brittleness. This phenomenon, just because. When we have more water molecules in the air, then in extreme weather, those water molecules then turn into ice. Of course, you've studied physics. The volume of our ice is larger than the volume of water because it's less dense. What about Hannibing? It is a solid. So many times. What if our connector? There are some of these engineering plastics, or some parts of the connector. It has a certain water absorption rate. Like the PA we use, nylon, then the water absorption is very obvious. What about in this case? It's a water molecule. It's a physical. Exists in our between the molecular chains of engineering plastics, and when it does, when it's ice, at this time, it will make your insulator. Will produce as we just talked about low temperature brittle, such a phenomenon. It's you who push a little harder, or you apply a force on the outside. It cracks easily. It's broken. Then this is low temperature brittleness. What about this phenomenon? Is it because your product is at high temperature, in high humidity and low temperature, due to this shared environment? So this so-called humidity. What about the damage? Is this also very deadly? What about the other case? This is a very special one. And, under normal conditions, not a very common phenomenon. Just, our high humidity and our low pressure? Under normal circumstances, if the humidity in our air is relatively high, it's actually very humid. It actually means something else. That means maybe our air pressure itself will be higher. Because under normal circumstances, the nitrogen in our air, that's about 78%. We have about 21% oxygen. So the rest of the gas is about 1%. Something like this. What about under the circumstances? If I contain water gas, under more circumstances, when the water molecules are relatively large. In fact, mine is under the same volume. My molecular density is high because water molecules are smaller than oxygen molecules. It has a lower molecular weight. So in this case, if I have a lot of humidity, it's normal. The air pressure will be higher. But there is also a way. Let's say we're in an alpine environment, high altitude. When we are at this high altitude, then the air humidity is relatively high. In this case, it will produce an extreme phenomenon. It is my product in the application process. It would say, well, this is my connector. Suppose I'm in a state where I'm already mating. Here is a sealed state. So in theory, the air pressure inside should be the same as the external air pressure. Is it a standard air pressure? Then if the current external environment is a less than 1 standard atmosphere of pressure, in such a situation, then it will have a phenomenon. Yeah, it's here, on this interface. It creates an air pressure difference. Internal air pressure will be greater than external air pressure. Then there is another situation. It is in this case. What if there are water molecules in my air? This water molecule. That is, if we have a lot of humidity. At this time, because of the air pressure difference, it forces the water to generate the phenomenon of condensation produces a condensation phenomenon. Because when your water molecules are condensed, then your air pressure will come down. Then your GR will come down. There will be a little bit of decline in part. It's a phenomenon like this. Condensation actually has a principle. There is a principle that is this principle. So what about some phenomena of this low pressure? It will make your product produce this change. And then when you're in your steam, after condensation, it becomes water. That water to our electrical connectors. Everyone can see the damage. This is a direct injury.